Okay, shall we start? I born. Okay, today we are going to discuss about linear motion, Puta. Last time we have discussed what is a linear motion and how to describe a linear motion. Okay, that was our last topic. Okay, can you remember it? Okay, when we are going to describe a linear motion, as I said you earlier, when you are going to describe a linear motion, we should consider three factors. What are those? Tell me quickly. What are those three factors? When we are going to describe a linear motion, we have to consider three factors. Using those three factors, we have to describe a linear motion. So what are those three factors? Tell me quickly. You can unmute and tell me.
Current position,
Yeah.
the moving way, and the moving direction.
Yes, very good. The current position, the direction of motion, and the way of motion, the way of moving. Okay. ඉන්නේ කොහෙද යන්නේ කොහෙද යන ආකාරය. Okay. ඉන්නේ කොහෙද යන්නේ කොහෙද යන ආකාරය. The current position, the direction of moving, and the way of moving. Those are the three factors we should consider when we are going to describe a linear motion. Okay. If you can describe those three factors, then you can fully understand about that linear motion. Okay. Okay. Under that three factors, we have discussed the first factor. What is that? The current position. Okay. We can recall our memory. Okay. Suppose there's a straight line. Current position means the current. Okay. When we are going to describe a linear motion, the first thing we have to do, we have to describe a starting point and a positive direction. That is our first precaution, or first thing we should do that. The origin or the starting point and the direction of the positive direction. Those two things we should define before describing any linear motion. With respect to these two notation, we are going to describe a linear motion. Okay. Then, after defining these two, what should I do? We have to describe those three factors. The first factor is the current position. The current position. The current position means whether the particular object is on the positive side or on the negative side. That is the definition of the current position. So suppose this object is in this side. That means we can say this object is in the positive side. If this object is in this side, then we can say the object is in the negative side. So that is the definition of the current position. Current position means the current location with respect to the origin, with respect to the starting point. Okay. Oh, actually, it is very clear if object is in the positive direction, or if object is in the positive side, you can clearly see its displacement. Displacement is positive. If object is in negative side, the displacement is negative. Therefore, we have discussed this thing. Therefore, the current position depends on the sign of displacement. If the displacement is positive, the current position is positive. The positive means the object is in the positive side. If the displacement is negative, the object is in the negative side. Okay. Can you remember that thing? Everyone, I need your responses. Okay. Suppose okay. Let me explain that thing. Okay. Suppose you are going to run 100 meters. You are going to run 100 meters. Okay. You are going to run 100 meters. Okay. If you are going to run 100 meters, actually, suppose this is the starting point. Okay. You are going to run, and this is the starting point. Okay. Now, suppose you have run some distance. You have run some distance. Okay. Then the distance that you have ran can be measured from this point to this point. No, this point to this point. This is your starting point. The starting point of motion, because you have start to run from this point. Therefore, this is the starting point of the motion, because you have start your motion from this point. So then you can measure the distance from this point. Okay, that is good. Okay, but you can measure the same distance from the other side. No, that can be done also. No? That can be done. Suppose this is the end point. This is the finish point. Suppose this is finish point. Initially, we can say is at this point. You are at this point. Then we can say now you were at this point. Now you are at this point. Okay. With respect to finish line, initially you have 100 meters away. Okay. Now, suppose this is 50 meters. Suppose this is 50 meters. Sorry, this is 40 meters. 40 meters and 60 meters. Now I can say, now you are close 60 meters. Okay, now you are close to finish line by 60 meters. No, initially you are 100 meters away from the finish line. Now you are away. Now you are away 60 meters from the finish line. Okay, so this is the measuring point. This is the measuring point. With respect to this point, we can measure the distance. Okay, but this is not your motion start point. No, you have start your motion from this point. So that is the difference. That is the difference. Okay. Measuring is motion start point means the start point of motion. The start point of motion. But we can measure the distance from anywhere. So distance can be measured from anywhere within this motion. So this point is called as measuring the starting point. Measuring starting point. Okay. If you are going to measure the distance from this location, then your motion starting point and measuring starting point are same. Okay? Did you understand it too? So that is the difference between motion starting point and measuring starting point. Okay.
Okay, sir.
Okay. Okay. Then, now we are going to discuss about the direction of motion. The direction of motion. Look at these two instances. Suppose I can use same diagram, okay? Suppose this object is moving into right hand side, that means positive direction. This one also. Okay, I can use same diagram. This is 1 and this is 2. This is 3, this is 4. Okay. Look at these 4 instances. This is number 1. Example number 1. Tell me. So where's the direction? So where's the direction of moving? In example number 1, where's the direction of moving, Puta? Into what direction? Into which direction? Either positive or negative. In example number 1, where's the direction of moving? Positive. No, you can clearly see, no? It is in the positive direction, no? Now ball is moving into positive direction. In example number 2, where's the direction of moving? In the example number 2, where's the direction of moving?
Negative direction.
Negative, it is into negative direction, no? Now ball is moving into negative direction. This one, example number 3, where's the direction of moving? It also negative direction, into negative direction. In fourth example, now it is moving into positive direction, no? You can clearly see if velocity is positive, that means if velocity is in positive direction, object is moving into positive direction. If velocity is in negative direction, object moves into the negative direction. Okay, therefore the direction of moving is decided by the velocity. Actually, the direction of velocity. If the direction of velocity is in positive side, the object moves into positive side. If the direction of velocity is in negative side, object moves into the negative side. Therefore, direction of moving is decided by the direction of velocity. There no other? Do you get my point? Okay. That is very important thing. Okay. The current position is decided by the sign of displacement, no? If the displacement is positive, the current position is in positive side. If the displacement is negative, then current position is negative side. Then the direction of moving is decided by the direction of the velocity. If it is into positive direction, then object moves into positive direction. If it is in negative direction, object moves into the negative side. Okay, write that one. Actually, we stopped last lesson after writing the topic, no? The second topic, the direction of moving or direction of motion. Last topic. The direction of moving or direction of motion. Moving or motion. Okay. After writing the topic, please draw this figure. Okay, but right under this figure. Direction of motion means the direction of motion means whether the object is moving into whether the object is moving into the positive direction or into the negative direction. Right in another paragraph. Consider the above four examples. It is very clear. If the velocity of the object is in positive direction, the object will move into the positive direction. If the velocity of the object is in negative direction, the object will move to the negative direction. Will move to the negative direction. Will move to the negative direction. Right in another paragraph. Therefore, the direction of motion, the direction of moving, direction of motion or moving, the direction of motion is decided by the direction of velocity, the direction of the velocity. Okay. Yes. Look at this. No? Now velocity is negative. No? In this case, velocity is negative. The negative or positive or negativeness of velocity can be determined by this direction. No. Initially, we have defined the positive direction. Initially, we have defined the positive direction. The meaning of positive direction means any vector quantity, any vector quantity into that direction will be positive. Any vector quantity into the opposite direction will be negative. Okay. According to that definition of the positive direction, you can clearly see this velocity, the number one velocity, is in positive direction. Therefore, its sign is positive. In this case, the velocity is in to the opposite direction of positive direction. No? That means negative. Look at this. Now, the positive direction is in right hand side, is in the right hand side. In this case, velocity is into the left hand side. Therefore, the velocity is negative. In this case, velocity is into the right hand side. That means it will be positive. Okay. So, in this case, velocity positive, velocity negative, velocity positive, velocity negative. Therefore, if velocity is positive, object is moving into positive direction. If velocity is negative, object is moving into negative direction. That's only. Then, okay. Write this one. Make a little photo karka. Okay. Then the third topic. The third topic means is the way of moving or the way of motion. The way of moving or motion. The way of moving slash motion. The way of moving slash motion. Okay. What does that mean? The way of moving. The way of moving means suppose these three instances. Okay, suppose. Okay. අර මම වෙල කිව්වේ මේකත් හරියට අපි අර මේ මොකක් හරි ගමනක් යනකොට අපි කියන්නේ මේක බස් එක වේගෙන් ගියා හොඳට වේගෙන් ගියා සමහර වෙලාව කියන අපි මේක ලොටලොටා ගියා මාර හිමින් ගියේ ලොටලොටා ගියා ඒ වගේ කතන්දර කියනවනේ ඒ වගේ කතන්දරයක් තමයි මේ අහන්නේ the way of moving means මේ how that object moves. How does that object move with time? Okay. Now, suppose these three examples. The first example, you can clearly see the velocity of that particular object increases with time. No? Initially it was at 5, now it is at 10. The second example, you can clearly see the velocity of that object decreases with time. No? Initially it was at 5, now it is at 1. The third example, the velocity of that particular object has not changed. No? So those are the three ways of moving. Okay, ways of moving means the change of velocity with time. The change of velocity with time. If the velocity increases with time, if the velocity increases with time, normally we say it is an acceleration. It is an acceleration. If the velocity decreases with time, normally we say this is a deceleration. Deceleration. If the velocity remains unchanged, we say the object moves at a constant velocity condition. Okay, so those are the three ways or three conditions of moving. Okay, three ways of moving. The object can move with an acceleration. The object can move with an deceleration or at a constant speed. Those are the three ways of moving. Okay, with acceleration, with a deceleration, or at a constant speed. Those are the three ways of moving. Therefore, the way of moving depends on the acceleration. Uniform velocity. Uniform velocity means constant velocity. Yeah. Both are same terms. So we can say it is moving at a constant speed, constant velocity, or a uniform velocity. That's also correct. Okay. Okay. Therefore, there are three ways of moving. The first one is increasing velocity with time. The second one is decreasing the velocity with time. The third one is the constant velocity condition. Those are the three ways of moving. Okay. So according to that figure, the factor that decides the way of moving is the acceleration of an object. The acceleration. Okay. If the acceleration has a magnitude and the direction is positive, that means it is acceleration. If an acceleration has a magnitude and the direction is negative, that means it is a deceleration. If an acceleration is equal to 0, that means a is equal to 0, that means the object moves at a uniform condition, on a uniform velocity. Okay. Hey or not? Did you understand? Okay. Others? Others? Okay, thank you. Thank you, thank you, thank you. Okay. Now we can write that thing. The third topic, the way of moving / motion. Under that topic, please copy this figure. Copy this figure. This is condition 1, 2, and 3. Okay. Right under that. The object, an object can have the above moving condition. The above moving condition. Okay. Listen to me. Listen to me, everyone. Actually, Buta, those are the three conditions. Actually, Any moving object, moving object can be categorized under one of these condition, no? Under one of these condition. Any moving object can be categorized under one of these condition. Okay. Therefore, those are the only three conditions that can, okay. Therefore, those are the three main condition of moving. Okay. Okay. මෙච්චර දීන්න පුළුවන්. මෙතනින් හැට තියෙන්න බෑ. Okay. If an object can have an acceleration or a deceleration or a constant speed. Okay, those are the only three conditions in the world. Okay. Okay. Oh, right under that, the velocity of object can be increased with time. Can be increased with time. Can be increased with time or decrease, can be decreased with time. If the velocity does not change with time, we can say the object is moving at a constant velocity. We can say the object is moving at a constant velocity. Therefore, there are three ways of moving. Okay. Those are three conditions. First one is acceleration, the second one is deceleration, third one is constant or uniform velocity. Acceleration means velocity increases with time. Deceleration means velocity decreases with time. Constant or uniform velocity means acceleration is 0. Acceleration is 0. Write these three. Right under this. Therefore, the way of moving is decided by the acceleration of the object. The acceleration of the object. Okay, I will use this. Okay, now I can summarize all the things. So what are the factors to be considered? What are the factors to be considered during the describing linear motion? The first one is the current position. So what is the deciding factor? Deciding factor of current position is displacement, no? Displacement. So the current position is decided by the displacement. If the displacement is positive, current position will be the positive side. If it is negative, the current position will be the negative side. That is the first one. The second factor is the direction of moving. So what is the deciding factor? It is the direction of velocity. Direction of velocity. Direction of velocity. If the direction of velocity is in positive side, the object will move into the positive side. Okay. If the direction of moving into direction of velocity is in negative side, the object will move into the negative side. Okay. So that is the deciding factor. The third one. Third one is the way of moving. So what is the deciding factor of moving? The way of moving. It is the acceleration of the object. If it has an acceleration, its velocity will increases with time, increase with time. If it has a deceleration, the velocity will decrease with time. Okay. If it doesn't have an acceleration, that means acceleration is 0, it will move at a constant speed or uniform speed. Okay. So therefore, acceleration is the factor that decides the way of moving. Okay. So the deciding factor is acceleration. Okay. Finally, we can conclude when we are describing a linear motion, actually we have to determine the displacement, velocity, and acceleration. Those are the only three factors: displacement, velocity, and the acceleration. If an object has a positive displacement, that means the object is on the positive side. If an object has a negative displacement, it is on the negative side. If an object is moving into the positive direction, that means it has positive velocity, or in other hand, if it has a positive velocity, we can say it is moving into the positive direction. So likewise, if you know the displacement, velocity, and acceleration, you can fully describe the linear motion under these three factors. Okay, what is the current position, what is the way of moving, so what is the direction of moving, what is the way of moving. So under these three categories, you can fully describe a linear motion. Okay, do you understand? Everyone, I need responses. Go. Okay,
Understood, sir.
okay, thank you. Okay, then draw this table, Puta. The first column, factors to be considered, factors to be considered, deciding factor. The second column, deciding factor. The first factor is current position. Deciding factor of that is displacement. Actually, positive or negativeness of displacement. Okay, listen to me. Everyone, listen to me. Everyone, please stop writing and listen to me. Okay. Look at my arguments. Okay. Look at my arguments. When we are describing linear motion, we have to consider only these three factors. What is the current position, and what is the direction of moving, and the way of moving. Those are the only three factors to be considered when you are describing a linear motion. Okay. So these three factors depend on these three vector quantities: displacement, velocity, and acceleration. Therefore, if you want to describe a linear motion, you should determine these three factors only. Therefore, suppose you are given a velocity time graph. If you are given a velocity time graph to describe a motion, you have to determine these three factors. What are those? Displacement, velocity, and acceleration using those graph. Okay? No matter what is the graph is, no matter what is the graph, whether it can be a velocity time graph, it can be a ST graph, it can be a AT graph. No matter what is the graph is, you have to determine these three factors using that graph. Okay? Suppose you are given a ST curve. If you are given a ST curve, you can clearly see the y-axis represents the velocity displacement. Okay? Therefore, you can clearly determine the displacement using the y-axis. No? If you consider a VT graph, velocity time graph, you cannot see displacement. No, you cannot see displacement because it represents the velocity and time. Then you should determine, you should fully understand. You have to understand how to determine the displacement and the acceleration using the velocity time graph. If you are consider a ST graph, if you consider ST graph means displacement time graph. Actually, there is only displacement. No? Then you have to understand. Actually, you have to understand how to determine other two factors. That is the way of describing velocity using a graph. Actually, if we take a graph, there is only one factor, either displacement or velocity or acceleration. Okay. If you are consider a ST graph, there is only S. If you consider VT graph, there is only V. If we consider AT graph, there is only A. Okay. Therefore, if you want to describe a linear motion using a graph, you have to consider the other two factors. Okay, you have to determine, not consider. You have to determine the other two factors using that particular graph. Okay, clear now? Others? Okay, thank you. Okay, write this one. මම පස්සේ ගියා දෙනවා මම මෙතනදී ගියා දුන්නේ මෙතනදී සම්බන්ධ කරගන්න පුළුවන් නිසා ඒ නිසා අපි අර ඕනිම graph එකක් use කරලා අපි describe කරන්න ඕන නම් පුතේ motion එකක් අපිට මේ factors තුන තමයි graph එකෙන් හොයාගන්න ඕනේ. එච්චරයි. අපි graph එකක් දෙන්නේ මොකක් හරි එක factor එකක් විතරයිනේ. ST curve එකක් නම් S විතරයි. VT curve එකක් නම් V විතරයි. ඊළඟට AT curve එකක් නම් A විතරයි. Therefore, if we take ST curve, we have to determine other two factors using the ST curve. Okay. Actually, you have to learn that thing, how to determine the other two factors. Okay. Shall I erase one? Erase this one? Shall I erase this one?
Yes, sir.
Okay. Okay, Pita. Okay. Now we can move to our big lesson. What is that? Graph. Graph. Okay. Write it. But before we move into the graph, we have to learn what are the ways of representing the linear motion. Okay. Actually, there are two ways of representing a linear motion. Okay. The first one is graphical method. Graphical method means, sorry, it is a geometrical method. First one is geometrical method. Geometrical method means it is a figure. We can represent a linear motion using a figure, Buddha. Okay. Okay. Actually, when we are representing the linear motion, we have to represent, or we have to mention, so what is the current position, what is the direction of motion, and the way of motion. Okay. We have to mention those three factors. Okay. Okay. Write a topic. Write a topic. Representing a linear motion. Representing a linear motion. Right under that, there are two ways of representing. There are two ways of representing a linear motion. When we are representing a linear motion, we have to mention the above three factors. The above three factors we have to mention the above three factors. Above three factors. Okay. Okay. The first method is geometrical representation. Write a topic. First one, geometrical representation. Geometrical representation. Actually, geometrical representation means, Buddha, if we represent a linear motion using a figure, we call it as geometrical representation. That means Actually, I have drawn some figures no, in previously. I have drawn some figures. Those are some examples for geometrical representation. Okay, we can use a straight line, to represent a linear motion geometrically. Okay. Okay. In this case, we have to consider few factors. The first thing is we have to define the starting point and the positive direction. That is the first thing. Then we should place or we should locate the object in the correct position. Okay. Suppose it is on the positive direction or it is on the positive side. Therefore, we can locate our object on the correct position. Then we can mark the direction of moving using arrow. If you represent those things, then you have mentioned the current position and the way of moving. Okay. Then we have to mention the current position and the direction of moving. We have mentioned that thing. Then we have to mention what is the we have to mention the way of moving. In order to do that, we can use a symbol. Normally, the way of moving depends on acceleration. Therefore, we have to mention the acceleration on this figure. It is very simple. You can simply mention that using this symbol. 2ms minus 2 or 0, anything. Or minus 3ms minus 2. Therefore, if you write a is equal to 2ms minus 2, that means it is an acceleration. If you say a is equal 0, that means it is moving at a constant speed. If you say a is equal minus 3, that means it is a deceleration. Therefore, we can simply represent all the things in this diagram. Okay. This is called the geometrical representation. Okay. Geometrical representation means it is a figure. It is a figure. Okay. Draw this one. Okay, right under that. Geometrical representation. The geometrical representation geometrical representation means means representation of a linear motion. Representation of a linear motion using a figure. Using a figure. Okay. Then second thing. Graphical representation. That means representation of linear motion using a graph. Okay. Uh, Actually, we are not going to learn about this thing. This is very easy thing, no? So this one is the main topic, the representation of linear motion using a graph. Using a graph. It is a graphical representation. Okay. So if you are going to represent a linear motion using a graph, we have to have very good understanding about a graph. Okay, how to draw a graph. Uh, actually, uh, how to draw up some patterns of this made that graph. Therefore, then how to describe a pattern of a graph. Such kind of things. We have to know each and everything in graph. Okay. Okay. Title topic. The second topic is graphical representation, Puta. The second topic. Representing a linear motion. Sorry. Sorry. Can you hear me now? Can you hear me?
Yes, sir.
Thank you. Then right under the topic, representation of, sorry, representing a linear motion. Representing a linear motion using a graph is called a graphical representation. Okay. Okay. Now we are going to learn about graph. Now, what is a graph? Tell me, what is a graph? Actually, I think you have learned a lot of things about graph in all stage. Okay. Therefore, tell me, what is a graph? What is a graph? Simply tell me, simple. Very simply tell me, what is a graph? What is a graph? Simply, very simply. Actually, graph is a drawing, no? It is a drawing. Yeah. No, those are very complicated words, no? Actually, as a simple words, graph is a drawing, no? Yeah. So actually, if you may get a drawing pad or something, you can write this kind of figures, no? Yeah. If you take a drawing pad or some drawing book, and if you draw this kind of things, you are calling this as a drawing, no? Therefore, very simple word, in very simple word, graph is a drawing, no? Graph is a drawing. Therefore, if you want to draw a graph, you have to consider only two factors. Only two factors. Okay. Actual graph is a drawing which is drawn
on the Cartesian plane. Normally, instead of drawing book, this drawing is drawn on the Cartesian plane. No? So graph, very simply we can say a graph is a drawing which is drawn on the Cartesian plane. Simply, no? Cartesian plane. So now we have to consider about Cartesian plane. Cartesian plane. You know this is the Cartesian plane. This is X, this is Y. So graph is a drawing which is drawn on a Cartesian plane. Therefore, when you are going to draw a graph, you have to consider only two factors. Only two factors. This is a drawing. This is a drawing. Therefore, when you are going to draw a graph, you have to consider only two factors. Can you imagine? So again, tell me now, what is a graph? What is a graph? It is a drawing which is drawn on the Cartesian plane. Then make it challenge. Okay, the Cartesian plane. Make drawing. Cartesian plane drawing. So we should consider. Actually, we should consider two factors. Can you imagine? The first thing is the location. The location. Where are you going to draw this graph? Where they are, because in Cartesian plane there are four coordinates. This is first, this is second, third, and fourth quadrants. Therefore, there are four places in the Cartesian coordinate. So the first thing you have to decide, where are you going? Where's this graph should locate? No, the location of the graph. The first thing you have to decide the location. The location, whether it is on the first coordinate, or on the second, or on the third, or on the fourth. That is the first thing. That is the first thing. Wow. If you decide the location, the second one is the shape. The shape. The location and the shape. If you know the location and if you know the shape, then nothing to worry. You can draw the graph, no? Never. Simply, no? Can you understand that part? Can you understand my argument? Because graph is a drawing. Graph is a drawing. Is a drawing on the Cartesian plane. Therefore, as this is a Cartesian plane, there are four chambers. No, there are four chambers. And therefore, when we are going to draw a graph, we should consider only two factors. What is this? We have to choose a right chamber location. Then we have decided shape. If you know both things, then you can draw the graph. Suppose you know the graph is on the first quadrant and the shape is a straight line. A straight line which is 45 degree with x-axis. Then this should be 45 degree with x-axis. If you know the location and if you know the shape, then you can clearly draw a graph. ලොකු දේවල් කියන්න ඕනේ නැහැ. සිම්පල් විදිහට graph එකක් කියන්න මොකද ඒක drawing එක. drawing එකක් නම් පුතේ අපි drawing එකේ location එකයි drawing එකේ shape එක තමයි බලා ගන්න. එහෙනම් graph එක කොහොමද decide කරන්න ඕනේ මොකද්ද? graph එකේ location එකයි shape එක. හරි. location එක decide කරන්න ඕන තියෙනවා points හතරක්. Okay. So there are 4 points to decide a location. But in motion graph, there are only two points. There are only two points. What are those and what is the reason for that? In motion graph, there are only two quadrants to consider. Not lazy, only two quadrants. So my question is, what are those locations, what are those quadrants, and what is the reason for that? Hmm? Hmm? Can you tell me? So what are the motion graph? Actually, may you know, because you have learned that thing in orders. What are the motion graph? Motion graph. Hmm? First and second. No. No. What are the motion graphs? Hmm? Okay, I will take. What are the motion graphs? You have draw ST curves, VT curves, and AT curves. Those are the only three. Okay. Displacement time, then velocity time, and acceleration time. Those are the three motion graph you have to learn within this syllabus. Okay. Actually, you have learned the motion graph in orders. Now we are going to learn that thing much more advanced. So, what are the two locations? Actually, there are only two locations. There are only two quadrants to consider in motion graph. So, what are those quadrants and what is the reason? Actually, in motion graph, we have to consider only first and fourth quadrants only. First and fourth quadrants only. Why? Yes, very good. That's very good. Because in every motion graph, the x-axis is time. It is time. X-axis is time. Okay. Time cannot be negative. Time cannot be negative. Therefore, in motion graph, we don't want to consider these 2 points. Much more easy now, no? Much more easy because we have to consider only these two, no? Whether it is first, whether it is on the first quadrant or on the fourth quadrant. Therefore, it is very easy. Because in a motion graph, the time measure the x-axis is time. Therefore, time cannot be negative. Time cannot be negative. Therefore, we have to consider only these two points on. Okay. Okay. Do you understand up to now? Okay. 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 Then write up main topic graph, motion graph, motion graph. Okay. Actually, this now it is very simple to draw a graph because there are only few patterns to draw. There are only few patterns. This is one pattern. This is one. This is another one. Same thing can be used here. Then we can curve these things. Curve these things. There are only these patterns. Okay. 1, 2, 3, 12, 12, 14. There are only 14 patterns. So there are only 14 patterns. Okay. Therefore, this is very simple. This is very simple. If you can understand each and every pattern may individually, then nothing to worry. Okay. Right under the graph or right on the topic. We can simply describe a graph as a drawing on the Cartesian coordinate, on the Cartesian plane, okay, on the Cartesian plane. Cartesian plane. Then we should understand how to draw this drawing. There are two factors to be considered when drawing a graph. The first one is location. The second thing is shape. The second thing is shape. Okay. right under that, right under that. In motion graph, in motion graphs, x-axis always represents the time. Time cannot be negative. Time cannot be negative. Therefore, the negative side of the x-axis won't be existed in motion graphs. Okay, look at this one. Marlon logic here. Okay. Okay, everyone, please look at the board. Marlon logic here. Please look at the please clearly understand my logic. Okay, it is very easy. If you understand that one, you can apply that into any kind of graph. Okay. So what is a graph? It is a drawing on a Cartesian plane. Okay. Now we are going to draw a motion graph. In motion graph, there won't be negative x-axis. Okay. Therefore, there are only two sides. First one and fourth one. Okay. Initially, we have clearly mentioned if you want to draw a graph, there are only two factors to be considered. So, what are those two factors? The first one is location. Where's the location? No, where should you draw this graph? Okay? That is the first thing you have to consider. Okay? කොතනද ඉන්නේ? ඒක තමයි. ඒ කියන්නේ කොතනද ඉන්නේ? ඒක තමයි වගේ කොතනද ඔයාගේ මේ graph එක draw කරන්නේ. ඔක තමයි consider කරන පළවෙනි factor. Where do you going to Draw this graph. Great. The second thing is the shape. The shape. If you know these two things, you can draw a graph. Now you can apply that knowledge into these conditions. Look at this one. Now we are going to describe about SVOA with time graph. Therefore, type won't be negative. Therefore, there are only two locations to be selected. No, there are only two locations. Either first one or fourth one. Tell me, everyone, I need your responses. Tell me, how to distinguish those two locations? How to decide? How to decide that one? Whether you are going to draw this graph on the first one or fourth one. How do you decide that? So what is the difference between the first one and second one or fourth one? What is the difference? What is the difference? Tell me. Actually, now I am going to explain the very important logic. So please listen very carefully, give me your fully attention and give the answers to. Yes, very good. Others? Yes. There's a no. I am not concerned about vectors. On the graph I can have it. Yes. So, don't think deeply. So don't go for vector quantities, other things. Okay. We can discuss those things later. Okay. Actually, I am very simply positive and negative relationships of what? Positive and negative relationship of what? Suppose this thing. I'm not actually, my question was, what is the difference between the first one and fourth one? Have I asked vector quantities again? Have I asked about vector quantities? Or any other relationship between velocity time or velocity so displacement time or anything? Please listen very carefully. Okay? My question was, what is the difference between fourth and first and fourth one? This is not about motion graph. My question was about points. Cartesian plane. My question was about the Cartesian plane. That is very simple. About Cartesian planes. Based on your knowledge about Cartesian plane, please give me that answer. So what is the difference between first and fourth one?
Positive and negative.
Positive and negative of what?
The values.
What values? Which values? Positive and negative of y-axis. No, why value? No. In the first one, the y values are positive. The fourth one, y values are negative. That is the only difference. No. The first and fourth one, there is only one difference. What is that? The first one, y values are positive. The fourth one, y values are negative. That is the only difference between first and fourth one. Very later. I need responses from everyone. or response දෙන්න දෙකක් තියෙනවා. අපිය මේකට සහභාගී වෙන්න මොකද මේ ඊට පස්සේ okay. Actually, I have asked about Cartesian coordinate. According to your knowledge about Cartesian coordinate, so what is the difference between the first coordinate and the fourth coordinate? That is very simple. The only difference in the first coordinate, y values are positive, right? Y values are positive. In fourth coordinate, y values are negative. Y values are negative. Y values are negative. So, if you consider ST curve, then if S is positive, your drawing should be on the first one. If S is negative, this should be in fourth one. On fourth one. Okay? Then we can consider other argument. If the particle or if the object is located on the positive side, that means S is positive, then the graph should be on the first one. If particle is on the negative side, S is negative, then the graph should be on the fourth one. Do you get my point? තේරුණාද? කොහොමද හිතන්නේ කියලා තේරුණාද ඒක? බලන්න ඒක මොකද ලේසි. හරියට තේරුම් ගත්තොත් හරිම ලේසි. So if we consider about SG curve, you know clearly if S is positive, means displacement is positive, that means it is on the positive side. The object is on the positive side. If the object is on the positive side, then the graph should be on the first part. If the object is in the negative side, then the displacement will be negative. Then graph should be on the negative fourth part. Right. Then tell me how to distinguish the first and fourth part in velocity time graph. Tell me. Velocity time graph. Well, velocity time graph पे कभी मैं first coordinate का fourth coordinate का distinguish कर गया velocity time graph पे. Others? Okay. Look at this one. If there's velocity time graph, the y-axis is velocity. So if velocity is positive, that means the object is moving into positive direction. If y values are negative, that means velocity are negative, object is moving into negative direction. Therefore, the direction of moving, that means the moving direction or the direction of velocity is the factor that describes actually according to the direction of velocity, we can decide what is the location of velocity time graph. If the velocity is positive, that means if the object is moving in positive direction, we can draw the graph in this way. So this means velocity is positive. That means object is moving into the positive direction. If I draw a graph like this, the velocity is negative now. Velocity is negative means the object is moving into negative direction. Same now. Same now, then. Others? We get about within the group. Right? Okay. Correct. Okay. Actually, we have discussed up to location and shapes in this one. Okay. Okay. After that thing, we have what is the last sentence? Can you tell me what is the last sentence? මොකක්ද අන්තිමට දුන්නේ පුතේ? Last sentence. Okay, good. Draw this graph. Draw this figure. Draw this figure. Draw this figure. Okay. After drawing this figure, write a subtopic. How to choose the location. 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 Wow, see the location. Okay, right under that. There are only two locations. There are only two locations within the brackets quadrants. There are only two locations within the brackets quadrants. There are only two locations to select. In a motion graph. In a motion graph. First one is first quadrant. The second one is second quadrant. The first one is first quadrant. The second one is fourth quadrant. First quadrant and fourth quadrant. Okay, no second. Sorry. First quadrant and fourth quadrant. First one is first quadrant. The second one is fourth quadrant. If y values are positive, if y values are positive, if y values are positive, it belongs to the first quadrant. First quadrant. Right in the next paragraph. If y values are negative, if y values are negative, it belongs to the fourth quadrant. Therefore, Therefore, positive or negativeness of y, positiveness or negativeness of y value, positiveness or negativeness of y value, therefore positiveness or negativeness of the y value, therefore positiveness or negativeness of the y value decides decides the location of the graph, the location of the graph. Okay. It is very clear. Okay. Look at the board. Now our argument is very clear. No? If y values is positive, the location is first quad. If y value is negative, the location is the fourth quad. That means if we are going to draw a street curve, we have to consider the positive or negativeness of S. If we are going to do a VT curve, we have to consider the positive or negativeness of V. If we are going to consider AT curve, we have to consider the positive or negativeness of A. Okay, that is the thing. That is the thing. Therefore, we have to consider the positive or negativeness of Y value. The physical quantity representing the Y axis. Okay. Therefore, that decides the location of the graph. Okay, the location of the graph is the Y value. Okay, location. Graph location decide Y A positive negative. Y value velocity velocity positive na අපි අඳින්නේ positive side එක. Y වල තියෙන්නේ displacement එකක් නම් displacement එක positive නම් අපි අඳින්නේ first part එක. If maybe we are going to do a AT curve, if A is positive, we are going to draw it on the first one. Otherwise, it is only fourth one. Hi. Okay. Now we know what is the factor that decides the location. Now we are going to study about the factor that decides the shape. A shape to be decided how. So what is the factor that decides the shape? Shape. The shape of a graph. The shape of a graph is designed by shape. You can see this is a straight line, no? This is a curve. This is another curve with another shape. This is another one. This is another straight line. This is curve in another shape. Okay. On. Okay. Those are the 40 shape. The shape. Again, I'm asking about graph, not about motion graph. Okay. Look at this one. This is a straight line. This is a curvature. This is another curvature, but curve into the other side. This is another curvature. This is a straight line. This is another curvature. So, actually, those are the shapes. Those are the only shapes we have. Okay? We have other shapes have. Okay. Actually, shape is decided by the gradient. We call it as gradient. Okay, we can. I will explain the thing. The gradient of the curve. Actually, you may know that one in oral stage in mathematics. I think you have learned that thing, the gradient. So the gradient is the factor that decides the shape of the curve. Shape of the curve. Final topic: how to decide the shape of the graph. How to decide the shape of the graph. Okay, draw this thing. Draw this one. There are two other shapes. This one. Okay, with it. Right on this. अब रंगा ले आगा वो लगते हैं. Weather condition के चुनाव बनाया होगी. ठीक है. මේක ඇඳ නැත්නම් ස්ක්‍රීන්ෂොට් එකක් ගාලා ගමන පස්සේ දාගමු ඇති දාගමු. Okay. Right under the graph. The shape may be a straight line. The shape may be a straight line. The shape may be a straight line or a curve.
Sir, can you please repeat from the beginning?
The shape may be a straight line or a curve. There are about 16 number of shapes. The shape of a graph. The shape of a graph is decided by the gradient of the graph. Okay. So today we have learned about graph, especially motion graph. So according to our simple definition, graph is a drawing which is drawn on the Cartesian plane. Therefore, so when we are drawing a graph, we have to consider two factors. What are those? The location and the shape. Location is decided by the positive or negativeness of the y-axis. Then the shapes. There are 16 number of shapes. We have to discuss about each and every shapes individually. We will learn that part in our next class. Then shape is decided by the gradient. We will describe that things in our next class. So this is decided by the gradient. So only we have to consider the positive or negativeness of the y-axis and the gradient. If you can decide that thing, you can draw a graph. Okay. Okay. So I have to complete today's class with now because today I have to complete the class little bit early. So if you have anything to ask up now. No. No. Okay. අපි Sunday class එක 7:30 පටන් ගත්තොත් මේ සතියේ විතරක් පුළුවන් වේද? 7:30 Sunday class එක. A little bit earlier. 7:30. පුළුවන් වේද? Okay. I will ask that. Okay. Thank you. Okay. So we can complete today's class with that. If you have any questions to ask, please may let me know. Then so okay, everyone. Good night. I want to say. Welcome.